Afternoon. It's lovely to be here. If you could have the next slide. My name's Jeff Hogg. I'm an assistant professor at the University of Birmingham, focused on AI implementation, and a clinical innovation officer at a large NHS trust in Birmingham too. And crucially for this, member of the National Data Guardian panel. And what I'm hoping to do is give you a bit of an overview of AI from a few different perspectives and its role in health and care. There's a part of me that always feels like a big fraud, having AI in my job title, in that I don't have a technical background myself. I'm an NHS ophthalmologist by background, and the research I do in this space is more on the kind of social science side of things. So hopefully that means that I make the technical aspects reasonably accessible, but it does mean that I might not be able to support more probing questions in that area. But if we could go to the next slide, that's great. Thank you. I'll give a bit of an overview of AI and some kind of definitions or classifications and different perspectives on what that is. Think a little bit about different types of technologies, and then from an adopter perspective, say healthcare provider organizations or social care provider organizations, think about what that can mean for governance. And then also we'll touch on a few specific kind of vignettes of how you might bump into AI in your practice, which I think will provide a bit of a scaffold for the conversations of the afternoon and help to kind of relate to what you might see in practice. So if you have the next slide, I'm going to touch a little bit on important kind of categories you could consider AI in. And it's always a bit challenging because definitions always shift and some of the territory is slightly contested. And so if you feel like it's confusing, that's probably because it is to some degree. And so I'm going to kind of take a couple of different lenses to point to key distinctions. Firstly, a kind of technical perspective, then thinking from a regulatory perspective, and then finally from adopters, so in provider organizations. So if we go to the next slide, we might see a diagram that is not uncommon in these kind of overview talks about AI. And the lines and interrelation of these categories can be debated a little bit, but hopefully it's a helpful kind of primer to see how these different terms you might encounter relate. So if we think of artificial intelligence as the broadest term here, I think that can mean a lot of different things to a lot of different people. The reason it's kind of the biggest shell here is because within some of those definitions, we can include rules-based systems that essentially automate a human logic, which doesn't align so closely with some of the newer technologies we hear of. Going in one rung from that, if you like, machine learning within artificial intelligence, the distinction there is often that the rules that are being automated and applied by these technologies, instead of being coded or sort of dictated by a human, they're learned from a set of data. And those kind of approaches have been around for a very long time. You could consider simple regression models within that, which also can get translated into sort of simple heuristics that you can hold in your mind and apply even. Within that, there's another category called deep learning, which is kind of responsible for the wave of enthusiasm and prominence we've had around AI since around 2012. And that really refers to the kind of degree of complexity of the computational systems that are delivering, if you like, these rules learned from data. The word deep refers to the number of layers within the computational architecture making this up. So it really just kind of refers to the complexity, if you like. And then within that, which is something that has been much more prominent in the last few years when we think of ChatGPT and other kind of tools that we've come across like that, is generative AI. So this is artificial intelligence that's capable of producing new text or images or even audio. And if you could have the next slide, then you'll see that generally the reason there's been such enthusiasm about these increasing waves of technological progress is because or it's not just that the AI or the technology behind it's more complex, but the performance and the scope of kind of tasks for which it's useful has also expanded, and so the kind of value it can offer seems to as well. But if we go to the next slide, it's also often true um, that it can be harder to understand or explain why it arrived at a certain output. If you think back to the beginning of this ramble about rule-based systems, it's very easy to say, oh, well, whoever coded it said, if the value is above this threshold, then take action A. If it's below that threshold, then take action B. And that's essentially a clinical guideline, potentially. But when we go down to the very bottom, it's much harder to explain the kind of behavior and output of these models, which can be quite troublesome in certain settings. I've also just noticed from this that I think the formatting on my slide might have slides has jumped a little bit as we've shared it. So apologies if there's some psychedelic colors as we go through. So if we go to the next slide, we can also think about breaking these technologies down by the kind of tasks they perform. And broadly speaking, there's a kind of top-level fork here between discriminative tasks, where the AI technology is trying to discriminate between different categories or values, perhaps, and generative tasks, where we're producing things like images. So there's an example there, slightly lighthearted and possibly not relevant, from a website. I think it's called thisisnotarealcat.com or something like that. And it's something that's been around for a few years, but essentially generates images. And technology's moved on a lot since that earlier example, but you can have large vision models like this, which create images, large language models, which create new text, and even multimodal models in that space, which can use audio, language, vision, those kind of things too. And in healthcare, those kind of technologies can potentially be used to test other AI models. So producing, say, image inputs to test a model on to see how well it does in certain cases. Or it can also be quite useful for clinical education. Say if there's a very rare disease, it's quite hard to get a medical image of that particular group of patients. You could have it generated by an AI model that provides examples. The other little box there, the ChatGPT logo, is there to kind of indicate or refer to large language models and their kind of role in healthcare, which can be summarization, which we've heard about with AI scribes and ambient voice technologies we'll touch on a bit later, and those kind of use cases. On the discriminative side, there are uses that have been around for a while. So regression is where the output is actually just a continuous number. So it might be, for example, the Q risk score is a good example that talks about your risk of a cardiac or event in the next 10 years, and it will give you a sort of percentage value. Or it might be a classification model, which looks at some kind of input data to say whether you have a disease or not, or perhaps put you in an urgent triage category or not. So it puts you in different categories rather than that kind of linear scale. And then segmentation models are another common thing in image analysis. So here you can see a CT chest helping to identify different tissues which may be used for treatment planning. So if we think of radiotherapy, for instance, it's very commonly used there for radiotherapy planning. Or again, it could be an explainability function for why a certain diagnosis has been made for a classification model running with that. Could I have the next slide, please? So apart from that kind of technical categorization, another really important lens to look at these things through is a regulatory lens. And a very significant line here is the medical device line, whether or not a health technology qualifies as a medical device or not. And the reason for that is because there's a very significant amount of quality assurance and external validation that needs to be done. That's a legal requirement for medical devices. Whereas health technologies that don't cross that line don't necessarily have the same level of oversight. And as you can see from this text lifted from the IMDRF, the International Medical Device Regulators Forum, the scope is actually pretty broad. So software in red is part of this, and basically any use for healthcare provision, so diagnosis, prevention, monitoring, treatment, or alleviation of disease qualifies it. And then the bottom bit is just kind of to say that If it's a drug, there's a separate set of regulations applying to that, not around devices. If we could have the next slide, please. But you can imagine that that covers a whole range of things. So there's more important distinctions than just whether it qualifies as a medical device or not. A tongue depressor is just a glorified lollipop stick, but that's a medical device. And an MRI scanner is also a medical device, but obviously quite a different entity. So if we go to the next slide, there's also a number of different risk classifications. So if you've ever heard somebody saying, oh, it's a CE class 2A or 2B, or it's a class 3 or class 1, this is a kind of subcategorization of medical devices. And those categories are assigned on a risk basis. So again, lifted rather than from a specific jurisdiction. This is from the International Medical Device Regulators Forum, and it shows you that risk-based classification, which relates to the degree of autonomy, if you look across the kind of column headers there, that the medical device has in care provision, so treating or diagnosing, driving, or just informing, and then also the criticality of the healthcare scenario in which it's intended to be used in. And basically those numbers in the grids 1, 2, 3, 4 relate to the perceived level of risk, and therefore the perceived level of sort of evidence and oversight required for that medical device to enter market. Now, there's a lot of work and cost incumbent on manufacturers to meet, particularly from class 2 upwards, these requirements. So there's incentive to underclassify, I suppose, from a manufacturer's perspective. So it does help to have a bit of an understanding of the basic principles under there, and make sure there's some due diligence around appropriate classification and quality assurance. Can we go to the next slide, please? So just to kind of map that to what is out there on market in terms of digital health technologies more broadly, there's this very large category of software digital health technologies. And within that, drawing on the technical definitions that we've been speaking about, you could consider some AI digital health technologies. And there's bound to be software components that are not AI enabled that the AI sits within, but just to say that it's a part of the whole. And then within that, there are AI digital health technologies for which the use crosses that line of the medical device definition. And it's AI as a medical device. If we have the next slide, please. So even within AI as a medical device, it's important to realize that there are varying levels of assurance. We mentioned that class system, and it's important to realize that class 1 medical devices, the manufacturers have essentially marked their own homework. So there is a legal requirement for them to do certain activities and degree of quality assurance, but it doesn't require a conformity assessment by what we call a notified or approved body, something like the British Standards Institute. Whereas class 2 devices and above have had that kind of sign off by an independent organization. It's also true that even the products that are on market, there are some that are very well established and have been used by lots of different adopter organizations, and there are some that haven't been around very long and may not have been sort of put into practice in our jurisdiction much, and could potentially be a bit riskier for the adopter if there's not so much precedent. And if we go to the next slide, it's also worth understanding that things aren't always entirely as they appear, and that's not necessarily because of any sort of malintent by any actors involved, but sometimes there are AI digital health technologies, if we look at the sort of dashed red box in the AI digital health technologies, that situate themselves outside of that medical device line. And I think ambient voice technologies, AI scribes, is a brilliant example of that. It's obviously recently seen quite a bit of controversy over whether or not they should be considered medical devices. And to some degree, there's some genuine ambiguity around there that's being worked through. But I think the answer is they are, just to speak to that particular example. And then outside as well in the software digital health technology space, increasingly as AI becomes very commonplace, if there's just a AI function within a larger software product, it wouldn't be that surprising for it not to be obviously declared by the manufacturer. So if you want oversight within your organization of any AI-enabled functions, it's something to be mindful of when you're considering new products coming in. Just to the next slide, please. So from a clinician, sorry, a formatting attack. From a clinician's perspective or a doctor's perspective, what does that really mean? How are these technologies different from other things in reality? Well, one thing is that just because an AI product is working well today, it doesn't mean that it's going to continue to work well into the future. And it doesn't mean that it's going to work well in another site rather than here, or even in another clinic rather than the clinic that we're thinking about. It's also true that because of what I mentioned about the increasing performance, these technologies can kind of be trusted with higher stakes roles, maybe around diagnosis or triage. And with that comes greater risk of harm potentially and scale of harm if it's deployed across a whole system. There's the black box issue of being able to explain why AI came with a certain output, which can be pretty challenging in certain use cases. And even if you're not convinced by any of those points that AI is different from other health technologies, a lot of people think it is. And in many ways, that's enough. Just the fact that it is perceived to be different to set it apart from other technologies. So if we go to the next slide, there are some implications for adopters around that. One is that there's a need for local and continuous monitoring because we need to know that it continues to be safe in this place. Just because it was safe once somewhere, that's not enough. We also need to make sure we've got robust governance processes that sort of recognize the scale and level of risk that's associated with particular AI deployments and implement appropriate oversight. There needs to be quite a bit of thought about whether a lack of explainability is an issue for certain use cases and if there's a way to deal with that. And then it's really important that it's a team sport and that various stakeholders are heard as AI technologies are implemented and come along as part of the journey. If we could go to the next slide, please. So quickly, I'll just nip through a few kind of AI myths that I often bump up against in the ecosystem. Particularly by innovators, you hear that AI is not regulated or is somehow outside the regulations, which is just not the case. It's just that perhaps the other sectors in which AI is being employed and some of the stakeholders behind it don't have the same regulations, so they're not so familiar with what's in place. Sometimes you hear worries of AI taking people's jobs. I think within the healthcare sector, to be honest, I don't think any technology yet threatens to be that transformative that it would do that. And also, there's so much capacity relative, I mean, so much demand relative to capacity that it doesn't seem like a particularly imminent threat if it is to come. Something you come up across sometimes is something called the in-house exemption for medical device regulation, which is actually designed around labs and in vitro tests for sort of histopathology and other things, which goes along the lines of, if you're using a test that you made yourself, then you don't need to go through the same rigor or the same degree of quality assurance of external approval and all that kind of thing. Unfortunately, and on the back of that, you get a lot of AI development for medical device purposes, potentially, or people thinking that that's appropriate. But it's important to be mindful that that's not necessarily the case, and it only applies if there's nothing on market doing that particular function. Another thing that people both worry about and celebrate is that AI is continuously learning on the job, which is obviously a lovely vision of how brilliant and personalized it could come to be as a technology. But I have only come across one AI medical device, which is a continuously learning model. Everything on market, as I understand it, is fixed in the medical device space, because once it's done some learning, it's essentially a new product and it needs to go through the sort of 18-month regulatory approval cycle again. Now, there are changes coming, both in terms of technologies and the regulatory approach to that might make that not the case in the future, but it's something to be aware of at present. And the last thing to mention is that within the UK setting, a UK CA mark, not a CE mark, is the requirement. But actually, for the moment in the UK, UKCA is, of course, of value and indicates access to market and seal of approval within UK systems. But also, we do accept the CE mark still from the European context, just requires registration with the MHRA as well. So we go to the next slide. I think I'm going to skip ahead actually a little bit. There's a little bit about kind of governance structures here, but I'll go a little quickly through it. I just want to make sure I finish on time. But on the ground, from the adopter perspective, what I'd say is that there's quite a range of readiness, essentially, going from little pockets of of activity within organizations where people have got a tool through locally, all the way down to what I consider to be the most mature situation where AI governance is sort of proactively resourced and the skills and processes are established. If we go to the next slide. And at that very kind of mature end, whoa, the formatting really has shifted. There's a number of different kind of groups that you often see in larger organizations that are able to kind of resource this. But some of the key features is having a central governance group for which AI is clearly within their portfolio. And across the organization, all kind of AI activity goes through them or they have visibility of it. Sort of coupled with a bit of a flying squad, an AI solution group that brings together the specialist expertise, which is very varied, including information governance, IT, commercial, digital teams, and clinical teams to kind of deliver on these projects responsibly. If we go to the next slide. And sorry, the formatting really has slipped. The kind of governance approach around this is something we've been looking at. So we've run a research project funded by NHSC and the Health Foundation called the AI Readiness Checklist. The idea of this is to try and help a bit of a leveling up of those different levels of maturity that we mentioned for AI among adopter organizations. And it's a tool which we hope to be sharing in the months to come, but essentially tries to point to the kind of risks that AI can bring in an organization and some concrete examples of how they can be managed. So if we go to the next slide, please. And just picking out from that, those kind of risk categories, some of the things that might be more relevant for Caldicott Guardians that came from that research project. One thing to consider, because of the kind of increased digital surface area, if you like, that AI data flows present, is the risk of kind of an increased risk of cyber attacks potentially, and it's really important to make sure that existing checks like the data security protection toolkit of suppliers, for instance, or there's an ISO standard around cybersecurity 27001, that they have evidence of that from suppliers. It's also true down that from the perspective of cyber attacks that can cause problems with accessibility to data for controllers, and the integrity from, or separately, there can be a challenge for integrity as well if these products are adding to the record, say generating context or text like AI scribes it's inaccurate. Another key consideration is the bias and equity piece, that AI is very sensitive to the population that it's trained on, and it may be that if it's deployed in a setting with a different population, the performance may not be so high or as expected in those groups. So you could lead to lower performance for some compared to others. There needs to be clarity on data flows, particularly in situations where it's processed on cloud, for instance, where those environments are hosted, what the accesses are from the suppliers, and what the data is used for. And then the final point is just around acceptability to the public. One of those things we touched on about AI being seen as different, one of the issues is that if there's concern around one type of AI, it's often conflated across different AI products. So it needs to be clear where AI is being used and acceptable to service users. And there also needs to be a consideration for accessibility. If they're patient-facing products and there's a requirement for a certain degree of digital literacy, that might present a new barrier to access for certain services and certain groups. Should we go to the next slide, please? Having shared all that doom and gloom, I do think it's also important to remember the potential benefits of AI, which are around increasing capacity in services which are obviously under a lot of demand, increasing quality, occasionally cost saving, though that is something that's more challenging and there's less evidence of so far, and in some settings improving staff experience as well. If we can move on to the next one. So before we move on to the vignettes, I just want to point to a really useful policy resource in this space. I'm part of the Centre of Excellence for Regulatory Science and Innovation in AI, and we're lucky to act as a secretariat for a partnership of the CQC, NICE, the HRA, and the MHRA, called ADAS, or the Artificial Intelligence Digital Regulation Service. And they've got a great website, which is a very accessible and kind of authoritative source of truth for policy around AI innovation across the life cycle. So it targets both the developers and adopters of AI technologies. And I'd really recommend it as a resource if you're looking for kind of practical advice for any queries that come your way. And if we go to the next one, this is just actually a bit more detail. If you want to look more into what Circe AI does, its focus is on the regulation of AI health technologies. And there's a deal of kind of community building and different research projects like the AI readiness checklist that we touched on earlier, which may be of interest. And if you go to the next slide, we are also running some educational resources in this space. So we host the NIHR supported incubator for AI and digital healthcare, and we have a demand-led monthly webinar series where we kind of tackle different issues that stakeholder groups are interested in about AI in healthcare. And we're also just launching an MSc in AI implementation at Birmingham University with week-long CPD courses if yourself or any of your team want to take a deeper dive into any of these issues. So if we go to the next slide, I'm just going to quickly run through, hopefully I'm not doing too badly for time, but do let me know if I am, 3 quick case studies that will come up through today's session. So if we go to the first one, just leave you to read that briefly. So try to position these as they may come up in your practice. So if we go to the next slide, this tool is around clinic attendance predictors, and it's something that tries to target essentially the rate of did not attend at appointments. It can often sit around the sort of 10% mark. And in a service provider's position when demand often outstrips capacity, there's a very strong drive to try and make those efficiency savings. So the idea is that these models predict which service users are more or less likely to attend, and that can inform either targeted reminders, so phone calls ahead of appointments, or one other use case, which is a bit more controversial that is sometimes proposed, is that it can inform the booking for a clinic. So clinics with a lot of service users that are not predicted to attend may be overbooked, if that makes sense. Then if we go to a second vignette, it's a short bit to read. And then if we go to the next slide, these products are one of the kind of success stories of AI in the NHS, with 100% uptake of these stroke AI tools across acute stroke providers within the NHS, service providers within the NHS. What they do is target a problem where certain types of stroke are amenable to a treatment that needs to be given quite urgently, called mechanical thrombectomy, which is the removal of the blood clot that's caused the stroke. But this is given in quite centralized units. So once a CT has been done, it needs to be quickly decided that they need this particular treatment and they need to get to a center that can do it. And the implementation of these products has basically seen more individuals that are amenable to this treatment getting it, and an improvement in outcomes as a result. And then if we go to the final one, again, a little bit of text here, something you'll be more familiar with. And then final slide from me, which is just to say that these technologies try to target the kind of, so if you could just move to the next slide, the degree of administrative burden on clinicians in clinics and other settings where there's quite a lot of administrative tasks in writing down notes from consultations and having to sort of be focused on a computer, which is often doesn't add to the experience of the consultation for service users. So the value proposition here is to essentially free clinicians time from taking notes and documentation during consultations and in other settings, and to help them to sort of have more time interacting face to face with patients and service users. So thanks very much for your attention through that. I'm just going to hand over now to Vicky Chico, who's a senior privacy specialist at the Office of the National Data Guardian, to focus in on this last use case a little more closely and the information governance aspects of it. So I'll hand over to you, Vicky, if that's okay.
Thank you so much, Jeff.